Human-computer interaction.
Human-computer interaction. Concerns and constraints for lethal. Concerns and constraints for lethal. Autonomous weapon systems laws. Guermantes Lilari B. Strategic and Innovative Group, LLC, Falls Church, Virginia 22046, USA. Abstract. Trust in autonomous systems, especially weapon systems, could be the most difficult technological challenge facing defense industries, militaries, politicians, and the public because the algorithms have to be trusted. Furthermore, the operator, the military, defense industry, politicians, and the public need to trust the system to also follow ethical and legal rules. This paper briefly describes the trust considerations, concerns and constraints regarding autonomous weapon systems, and concludes with a brief description of the current development programs and projects by the various U.S. military services. Keywords: artificial intelligence auditability, autonomous confidence, controllability, environment explainability, human-machine interoperability, lethal autonomous weapon system, risk reliability, safety scalability, supervisability, traceability, transparency, trustworthiness, unmanned aerial vehicle, unmanned ground system, unmanned surface vehicle, unmanned underwater vehicle. Human trust in technology is based on our understanding of how it works and our assessment of its safety and reliability. To trust a decision made by an algorithm, we need to know that it is reliable and fair, that it can be accounted for, and that it will cause no harm. We need assurance that it cannot be tampered with and that the system itself is secure. We need to understand the rationale behind the algorithmic assessment, recommendation or outcome, and be able to interact with it, probite, even ask questions. And we need assurance that the values and norms of our societies are also reflected in those outcomes. Moving forward, build for performance will not suffice as an AI design paradigm. We must learn how to build, evaluate, and monitor for trust. 1. Italics by author. The above quote describes technologies that industry, such as IBM, and others shave with artificial intelligence and autonomous systems, and helps identify technical, legal, and ethical aspects of the problem. Much of the discussion regarding lethal autonomous weapon systems laws, in the media, academia, human rights organizations, and among governments have been about legal concerns of employing laws. This paper highlights considerations, concerns, and constraints regarding trust between the human-machine interface and laws. Copyright the author S. Under exclusive license to Springer Nature Switzerland AG 2022 T. RM&R. Taylor eds. eHyatt 2021, LNNS 319, pages 3 to 10 2022. https://doi.org/10.1007/978-3-030-85540-6_1. For G. Lilari. What is trust? The National Institute of Standards and Technology NIST is tasked to provide guidance on standards for technology in the U.S. Trust can have a simple definition, such as the confidence one element has in another that the second element will behave as expected. 2. Trust can also be defined in a very technical manner, such as the 17 technical concerns that can negatively affect products and services. 1. Scalability. 2. Heterogeneity. 3. Control and ownership. 4. Composability, interoperability, integrity and compatibility. 5. Ilities, non-functional requirements. 6. Synchronization. 7. Measurement. 8. Predictability. 9. Specific testing and assurance approaches. 10. Certification criteria. 11. Security. 12. Reliability. 13. Data integrity. 14. Excessive data. 15. Speed and performance. 16. Usability. And 17. Visibility and discovery. 3. In addition to these 17 technical trust concerns, 2 additional non-technical concerns are included. Insurability and risk management. 3. In the case of military autonomous systems, insurability is not relevant, but risk management certainly is. At the end of the day, trust is earned and cannot be assumed. A NIST Internet of Things, IoT paper ends with a cautionary note. For instance, humans are prone both to over-trusting and to under-trusting machines depending on context. Challenges also exist for measuring the performance of human AI teams, conveying enough information while avoiding cognitive overload, enabling humans and machines to understand the circumstances in which they should pass control between each other, and maintaining appropriate human engagement to preserve situational awareness and meaningfully take action when needed. 4. Trust is further complicated when the machine does not work properly and military or technical personnel attempt ad hoc repairs, and the results could be disastrous. If the technology employed is unstable, personnel may avoid using the equipment or may develop ad hoc and informal fixes to perceived weaknesses. The resulting gap between senior leaders' performance expectations and actual performance introduces another source of uncertainty into senior leaders' understanding of the combat situation. 5. These challenges also describe the challenges military personnel will face as autonomous systems are phased into operational units. As militaries around the world develop and use various autonomous systems, and as these systems become weaponized, military personnel will have to trust these systems. Some NIST definitions will provide a common lexicon to use in this paper. Risk. A measure if the extent to an entity is threatened by a potential circumstance or event, and typically is a function of 1. The adverse impact or magnitude of harm that would arise if the circumstance or event occurs, and 2. The likelihood of occurrence. 6. Trustworthiness. The attribute of a person or enterprise that provides confidence to others of the qualifications, capabilities, and reliability of that entity to perform specific tasks and fulfill assigned responsibilities. 6. Trustworthy information system. An information system that is believed to be capable of operating within defined levels of risk, despite the environmental disruptions, human errors, structural failures, and purposeful attacks that are expected to occur in its environment of operation. 7. Human and Machine Trust Considerations, Concerns and Constraints Laws 5. Weapon System. A combination of one or more weapons with all related equipment, materials, services, personnel, and means of delivery and deployment, if applicable, required for self-sufficiency. 7. In general, trust involves risk because it involves depending on another. When a person uses an autonomous system, the individual assumes the system will perform as designed and not have an unintended engagement. In other words, the system has expected results, positive outcomes and negative avoidance. In reviewing the literature on artificial intelligence, trustworthiness, reliability, risk, safety, challenges, control, and related synonyms are used to describe the trust relationship. The antonym of these terms are also used to describe outcomes such as untrustworthy suppliers, insertion of counterfeits, tampering, unauthorized production, theft, insertion of malicious code, and poor manufacturing and development practices. 6. Ethical and legal considerations of trust are primary to public policy discussions. For example, former President Trump's executive order on promoting trust with AI in the federal government highlighted on the following. Agencies must therefore design, develop, acquire, and use AI in a manner that fosters public trust and confidence, while protecting privacy, civil rights, civil liberties, and American values, consistent with applicable law. 8. The National Artificial Intelligence Research and Development Strategic Plan 2019 update offers an example that covers technological and the political dimensions. Beyond being safe, secure, reliable, resilient, explainable, and transparent, trustworthy AI must preserve privacy while detecting and avoiding inappropriate bias. 9. The NIST concentrates on technical aspects of trustworthiness in implementing trust in AI to meet the intent of the political leaders. Europe is also involved in trust and artificial intelligence. For example, the European Commission defines trustworthy AI in terms of 3 components. 1. It should be lawful, ensuring compliance with all applicable laws and regulations. 2. It should be ethical, demonstrating respect for and ensuring adherence to ethical principles and values. And 3. It should be robust, both from a technical and social perspective, because, even with good intentions, AI systems can cause unintentional harm. 10. The European Commission, EC, guidelines further elaborate that in order to ensure that artificial intelligence is trustworthy, it must ensure that the development, deployment, and use of AI systems meets the 7 key requirements. 1. Human agency and oversight. 2. Technical robustness and safety. 3. Privacy and data governance. 4. Transparency. 5. Diversity, non-discrimination and fairness. 6. Environmental and societal well-being. And 7. Accountability. 10. The EC guidelines deal with technological and political dimensions. Interest in artificial intelligence is exploding in global scientific, policy, and public interest arenas. For example, People's Republic of China PRC documents emphasize AI's technical aspects. While vigorously developing AI, we must attach great importance to the potential safety risks and challenges, strengthen the forward-looking prevention and guidance on restraint, minimize risk, and ensure the safe, reliable, and controllable development of AI. 11. China's Ministry of Technology AI governing principles reflect the same concepts. AI systems should continuously improve transparency. 6G Lilari. Explainability, reliability, and controllability, and gradually achieve auditability, supervisability, traceability, and trustworthiness. 12. The PRC documents emphasize the technical aspects of trustworthiness, and not the legal and ethical aspects reflected by senior U.S. political officials and the EC. Just as military personnel will have to develop and maintain trust in laws, trust will also have to be established and maintained throughout the law's lifecycle. That is, the design, development, deployment, maintenance, and upgrades. Interestingly, the Department of Defense Directive .3000.09 does not refer to positive outcomes as a design criterion. .3000.9 defines the goal of autonomous systems as to avoid negative outcomes, unintended engagement, or experience a loss of control. 13. The lack of a reference in the DOD for a positive outcome for laws could be a weakness in the directive, and should be reviewed to emphasize administration intent. To ensure the weapon system performs as designed, more importantly, the military will have to consider the impact on trust when laws does not perform as designed or does have an unintended engagement, or experiences a loss of control. 13. In other words, when laws does not perform as designed and breaks trust. By highlighting the unique trust considerations, concerns, and constraints between the military person and laws, the DoD will be in a better position to provide employment guidance for these systems. NIST Trust and Artificial Intelligence 2021 explains in clear language the AI revolutionary challenge, why trust is so important and difficult to implement. The artificial intelligence, AI revolution is upon us, with the promise of advances such as driverless cars, smart buildings, automated health diagnostics, and improved security monitoring. Many current efforts are aimed to measure system trustworthiness through measurements of accuracy, reliability, and explainability, among other system characteristics. While these characteristics are necessary, determining that the AI system is trustworthy because it meets its system requirements won't ensure widespread adoption of AI. It is the user, the human affected by the AI, who ultimately places their trust in the system. The study of trust in automated systems has been a topic of psychological study previously. However, artificial intelligence, AI systems pose unique challenges for user trust. AI systems operate using patterns in massive amounts of data. No longer are we asking automation to do human tasks, we are asking it to do tasks that we can't. Moreover, AI has the ability to learn and alter its own programming in ways we don't easily understand. The AI user has to trust the AI because of its complexity and unpredictability, changing the dynamic between user and system into a relationship. Alongside research toward building trustworthy systems, understanding user trust in AI will be necessary in order to achieve the benefits and minimize the risks of this new technology. 14. These same issues described in the NIST document affect trust and laws. Next, we will examine each of the U.S. military services autonomous systems, starting with the U.S. Marine Corps, Navy, Army, and ending with the Air Force. The Commandant of the Marine Corps, General David Berger, stated in February 2021 that the service needs to make some big changes in a few short years to stay ahead of China's growing military capability, but one of the biggest hurdles he sees is a lack of trust in the new unmanned and artificial intelligence systems he wants to invest. Human and machine trust considerations, concerns and constraints laws 7. We have programs right now, capabilities right now that allow for fully automatic processing of sensor-to-shooter targeting, but we don't trust that data. And West will ensure that there's human intervention at every step in the process. And of course, with each intervention by humans, we're adding more time, more opportunities for mistakes to happen, time we're not going to have when an adversary's targeting our network. We have the ability for a quicker targeting cycle, but we don't trust the process. 15. The March 2021 Department of the Navy's Unmanned Campaign Plan describes its vision for the Navy as to make unmanned systems a trusted and sustainable part of the naval force structure, integrated at speed to provide lethal, survivable, and scalable effects in support of the future maritime mission. 16. Additionally, the Chief of Naval Operations, CNO, released his AI Plan 17 that states the following. Unmanned platforms play a vital role in our future fleet. Successfully integrating unmanned platforms, under, on, and above the sea, gives our commanders better options to fight and win in contested spaces. They will expand our intelligence, surveillance, and reconnaissance advantage, add depth to our missile magazines, and provide additional means to keep our distributed force provisioned. Furthermore, moving toward smaller platforms improves our offensive punch, while also providing affordable solutions to grow the Navy. 17. The Plankelsford Navy to develop, test and deploy minutes systems to perform the dull, dirty, and dangerous missions. Some of the systems in development are the MQ-25A Stingray, unmanned carrier-based refueling tanker, Overlord unmanned surface vehicles, USVs, Sea Hunters, and Ghost Fleet Overlord. 18 and 19. The USMC is developing and testing systems such as Supply Glitterfort HATDRPA has assisted with heavy-duty cardboard gliders which can deliver supplies and then disappear in a span of days, and although they are reusable, they are designed to be expendable and biodegradable. These small gliders can be released by aircraft to deliver critical supply airs to a precise location defined by ground troops. The supply gliders features avoid the problem of inaccurate deliveries, a need to recover the system after deployment, as well as the cost of resupply systems, parachute or UAVs, that must be retrieved as well as other challenges of returning logistical systems such as batteries that displaces payload capacity, as well as launch/land infrastructure. 20 cardboard UAVs would be difficult to detect and to shoot down, and could be designed to deliver warheads. In effect, they would be inexpensive stealth systems. Instead of a transport aircraft being a logistical system to support ground troops, it could also deliver a massive strike via an airdrop. The USARMA is developing Hedvin-said targeting Gonlethal automated system, Atlas, that will artificial intelligence and machine learning to drive ground combat vehicles autonomous targeting capabilities, allowing weapon systems to acquire, identify, and engage targets at least 3x faster than the current manual process. 21. MOVING to a higher level of operations. Project Convergence is a U.S. Army program that connects any sensor to the best shooter. Project Convergence has two subprojects. An automatic target recognition AIs that are machine learning algorithms process the massive amount of data picked up by the Army sensors to detect and identify threats on the battlefield, producing targeting data for weapon systems to utilize. The AI Fire. AT-LILARI. Control fire synchronization to optimize responses in multi-domain operations or Firestorm, incorporates targeting data from the other AI systems. Firestorm automatically looks at the weapons at the Army's disposal and recommends the best one to respond to any given threat. 22 elements of Atlas and Project Convergence were tested in late 2020 at Yuma Proving Grounds. Other countries are developing their own UGVs such as AI-driven and tracked combat UGVs like Bogomol, Belarus, Vikir, Russia, Ripsaw, USA, Giant Tiger, China, and our research indicates that 33% of future warfare will be unmanned, and deployment of Unmanned Combat Ground Vehicle, UCGV, can provide a tactical advantage and technological superiority in the war. 19. In response to great power competition in air, land, sea, space, and cyberspace domains, the USAF S&T strategy declared, rather than reacting to others' advances, the Air Force will set an unmatched pace. Instead of looking at where potential adversaries are heading, the Air Force scientific and technical enterprise will predict where adversaries cannot easily go, and then ensure the Air Force gets there first. 23. Using this framework under global persistent awareness, the USAF must develop capabilities that provide on-demand awareness of adversary actions anywhere on the globe by securely gathering, processing, and fusing multiple types of trusted data from a large, diverse set of sensors. 23. Under rapid, effective decision-making (INETIA), the USAF seeks to realize the potential of artificial intelligence. The Air Force scientific and technical enterprise must push well beyond developed commercial applied cations in overcoming major challenges to effective military employment. These include unpredictable and uncertain physical environments, noisy and unstructured data from dissimilar sources, limited training data for machine learning, and the high levels of trust required to support lethal combat operations. Human effectiveness research in cognitive science, data presentation, and human-machine interfaces is also vital to optimize human-machine teaming performance. 23. Under complexity, unpredictability, and mass, the USAF plans to augment its high-end platforms with larger numbers of inexpensive low-end systems. With swarms of low-cost, autonomous air and space systems can provide adaptability, rapid upgradability, and the capacity to absorb losses that manned systems cannot. 24. In other words, the USAF will need to control large numbers of autonomous systems coordinated with traditional manned assets, and that artificial intelligence advances are needed to achieve high levels of intelligence in small, embedded systems and execute complex missions with trust. 23. The USAF autonomous systems seek to deliver additional firepower. The USAF Autonomous Weapon Systems program name is the Vanguard program and consists of 3 programs: Skyborg, Golden Horde, and Navigation Technology Satellite 3, NTS-3. The Skyborg program Isofleet of Robotic, Loyal Wingmen, A new class of autonomous drones with 15 different potential mission sets. The Australian military has a robotic wingman that the USAF is considering. A U.S. defense company, Kratos Defense and Security Solutions, has proposed the XQ-58, a Valkyrie experimental drone for a mission separate from Loyal Wingmen, and a low-cost attritable strike demonstrator program, which has conducted several successful test flights. 24. The U.S. Navy, USMC, and the U.S. Army have focused on developing logistics/supply autonomous systems before they develop autonomous weapon systems. The USAF has Human and Machine Trust Considerations, Concerns and Constraints Laws 9. Taken a different approach to the development of unmanned systems by concentrating on creating autonomous weapon systems that augment the firepower of fighter aircraft. 25. One implication of the USAF strategy is to reduce the number of pilots needed for hazardous missions, and eventually, to remove pilots from extremely high-risk missions. While the U.S. Navy is developing an autonomous air refueling tanker, the USAF has not mentioned going down this path. 25. The USAF has discussed developing and testing unmanned aircraft HAT, Crewed Element Soft Future Advanced Battle Management System, ABMS, a command and control, communications and data sharing network architecture. 26. The Golden Horde program is envisioned as a collection of small networked expend-able drones integrated by data link radios and collaborative behaviors that can use data links to communicate, choose targets based on pre-programmed algorithms, and then coordinate strikes against an array of targets independently from the human pilot. The program also is testing a swarming munitions concept that allows for collaborative weapons that can share target information and autonomously coordinate their strikes after launch, which could help maximize target damage and compensate for weapons lost in flight due to enemy defenses or other factors. 27. NTS-3 is designed to be a non-GPS position, navigation and timing PNT capable ITY. 28. Finally, another Air Force autonomous Broghermes R2D2, named after Thedroid from Star Wars, which is to provide a more robust autonomous air-to-air capability. 26. In summary, the short paper on Trust Stanley Thal Autonomous Weapon Systems expose challenges, concerns and constraints that affect the employment of autonomous systems. The primary problem is translating trust into an algorithm that functions throughout the life cycle of a military autonomous system. A secondary problem is ensuring trust remains as AI develops, learns and matures over time. A tertiary problem is ensuring that all systems and subsystems and their respective algorithms are compliant with NIST trust standards, but also when they interact with other systems. As the various military worldwide build autonomous systems, including laws, the technical, the legal and the ethical challenges, concerns and constraints will become the modern Gordian knot that will not be solved by simply cutting it. Ensuring trust, not over trust and not under trust, is the crucial task that technologists, military personnel, politicians and the public must solve. These autonomous weapon systems become a more complex, more lethal and more ubiquitous.
A multimodal approach for early detection of cognitive impairment from tweets Nirmalya Thakur, B. and Chia Y. Han, Department of Electrical Engineering and Computer Science, University of Cincinnati, Cincinnati, Ohio 45221-0030 USA. Thakurna@mail.uc.edu, han@ucmail.uc.edu. Abstract. The proposed approach can filter, study, analyze, and interpret written. A multimodal
A multimodal approach for early detection of cognitive impairment from tweets. Nirmalya Thakur, B. and Chia Y. Han. Department of Electrical Engineering and Computer Science, University of Cincinnati, Cincinnati, Ohio 45221-0030 USA. Thakurna@mail.uc.edu, han@ucmail.uc.edu. Abstract. The proposed approach can filter, study, analyze, and interpret written communications from social media platforms for early detection of cognitive impairment, CI, to connect individuals with CI with assistive services in their location. It has 3 novel functionalities. First, it presents a big data-centric data mining methodology that uses a host of natural language processing and information retrieval approaches to filter and analyze tweets to detect if that tweets were made by a user with some form of CI, for instance, dementia. Second, it consists of a string matching functionality that uses the Levenshtein distance algorithm and fuzzy matching to score tweets indicating the degree of CI. Finally, the framework consists of a text mining approach for detecting the geolocation of the Twitter user so that, if the user is cognitively impaired, caregivers in that area could be alerted and connected to them to facilitate early-stage care, services, therapies, or treatment. Keywords: natural language processing, data mining, big data, elderly population, cognitive impairment, dementia, geolocation, Twitter. 1. Introduction. Dementia, a form of cognitive impairment (CI), develops slowly, but it is common in the rapidly increasing elderly population, which currently stands at 962 million globally. At present, there are around 50 million people worldwide who have dementia, and this number is projected to double by 2032. The costs of looking after people with dementia and other forms of CI are a global concern. In the United States alone, these costs are estimated to be around $355 billion in 2021 and are projected to rise to about $1.1 trillion by 2053. Thus, early detection of dementia endotherformsoft is essential for providing assistive care services to reduce the associated long-term healthcare and caregiving costs. Over the last few years, social media platforms have evolved and transformed into virtual spaces via which people from all demographics communicate with each other to form their social support systems for and develop online interpersonal relationships. 5. Recent research shows that people use different social media platforms to seek support, share information, and communicate with others when they face various forms of CI, and are in the early stages of the same. 6. 7. Copyright the author S. Under exclusive license to Springer Nature Switzerland AG 2022 T. RM&R. Taylor eds. eHyatt 2021, LNNS 319, pages 11 to 19 2022. https://doi.org/10.1078783-030-85540-6_2. 12 in, Thakur and C. Y. Han. Early diagnosis of CI such as dementia has several benefits. 8, such as improved quality of life, probability of pharmacological and non-drug treatments to have maximum effect, delaying transition into care homes, better treatment of dementia-related depression, reduced behavioral disorders and increased independence during activities of daily living. Communication difficulties, Botha-Noralandretin communications, are considered one of the earliest symptoms of SIN. This paper presents a brief review of related works and gives the rationale for the new approach in SECT. 2. Section 3 presents the multilayered framework as the solution. Section 4 shows how this framework was implemented using a data science tool and discusses the obtained results of detecting CI from tweets, followed by the concluding remarks in SECT. 5. 2. Literature review. Cavadoni et al. Presented a virtual reality-based approach for detecting CI in the elderly. The paper also outlined the approach of study